You ready to go on? Good. Welcome everyone. Thank you for joining us here, live, in person, or virtual. I'll give it over here to Gino Canessa, who is a principal software engineer at Microsoft, for the introduction to FHIR search.
Oh.
Thank you.
Thank you, Ward. Hello, and yeah, as Ward said, welcome to Introduction to FHIR search. My name is Gino Canessa, and I will be your tour guide for this section of the spec today. The quick minutia. Oh, Word, I don't have slides on the screen though. So, hey, there we go. Now there's it. On the bottom, there is aka.ms/devdays-Gino, and you can get your own copy of the deck there and things like that. So there'll be a fair number of links in here, and you can go grab that. And I believe there'll be copies through Whova as well at some point. So if they're not there already, you can grab them there. But it means you don't have to take notes. The quick TLDR about me, I'm a software engineer at Microsoft. I'm actually in the research side. So we're entirely on healthcare standards and interop, which is great because I can come talk about search, but I cannot help you with your Azure questions because I have no idea. So apologize for that. I've been doing this for a few years now. Prior to FHIR, I was working in DICOM, mostly in interchange there, which is a different story because it was CD based at the time. And in our defense, they were a great idea at the time. We also thought they had a shelf life of about 5 years, and then they would all be replaced. Still counting on that happening at some point soon. And there's contact information for me as well. My email address, you can try. I will try to get back to you if you do. Zulip is definitely the best place to get a hold of me, chat.phir.org. And there's a link to YouTube where I post educational content. So before we get into search, a few disclaimers. First is search is big. If you've pulled up the spec page, you have probably realized that it's big. It touches most of the spec, and I don't know if I can say most use cases or many use cases, but either way, there's a lot to it. So there's no way we're actually going to cover everything on search in 45 minutes, but we will try to get through what we can. I do want to mention defined does not equal implemented. And this is hopefully something that you've been hearing today. If you're new to FHIR, the spec is going to cover a lot of things, and we try to keep to the 80% rule. So anything added to the spec covers a large chunk of the use cases. But that doesn't mean that every server will have it implemented. So we'll try to touch on things that you can expect to be implemented pretty much everywhere, how to find out if it's implemented, and then touch on things that are probably not going to be implemented. And then also, I'm not going to cover GraphQL. For the not implemented, I'll say because it's specific to use case. I could see the question there. There are some features that unless you have a very specific use case that you know has been implemented on a server, you're not going to find it. But if the spec is there, that's the ability for you to go implement it in a consistent way and or to ask for it to be implemented if it's something you need. So live audience, it's fantastic. So yeah, so what are we going to cover? Like I said, basics, some use cases, examples. I'll have VS Code, HTTP extension files, and Postman collections for everything. I have some outputs. They're all on GitHub. So you can look and poke and prod yourself as well. We'll try to get a broad view of what's available in search, and that way you can kind of see what's possible. And then I will have these two links to a lot of things. The first one is the current published documentation, and that's, you can see just hl7.org/FHIR/search.html. That is the search page. However, we are working on rewriting the search page because there's a lot of stuff that needs to be updated. And that is in this continuous integration branch. So these are changes that are not approved. They aren't published yet. They're all just essentially rewriting, reformatting, changing all the examples, updating, adding all the stuff that's been there. So I linked to it in a few places just because some of the tables and things are a lot clearer in the newer version already. We're hoping to have that in for the R5 ballot. So that'll be published hopefully soon. So search. Most of FHIR is, the most common is RESTful stuff. And so we're going to be generally using that here. Search does work in FHIR messaging and different things like that, which you shouldn't worry about unless you absolutely have to. It is get versus post. There's a discussion debate about that, and we'll dive into that a little bit. You do want to pass data into your search. It's definitely a more useful search if you can ask for specific things instead of searching for everything. So we'll go through that and what you get back. And I have the hint there, it is not an array of resources. So if you're coming from a standard REST world where you get an array back, that is not what you get here. And then we'll also touch on relating resources. So relationships between them, chaining, including all kinds of fun stuff. So a search request. We'll start with a URL. It has a search context and it varies for get and post. And then you add in search parameters, your inputs, your filters, whatever. And as I said, the deck is link heavy. That's why I would encourage you to download if you're interested. There are the links for where it is in the current documentation, the HTTP page that specifies how you talk to it via REST, the search introduction, and then the work in progress for search introduction and transport protocols. So there are the examples. There's 3 contexts available. The first one is the server root, and that is saying it's a system-wide search. So it's any resource, anything that's there, you can just ask for. There are search parameters defined that you can restrict types, different things like that. But you can see for a get, you're just getting on the root URL. So there's an example there. And for a post, you're appending this path segment of _search. Now, in general, all the things in search are going to be prefixed with underscore if they're global defined things. And the search post URL is no different. So the underscore search, so it doesn't conflict with anything else. That's the deal there. It does mean it's not a valid ID. So if you're ever trying to use an ID of _search on a resource, you can't use it because it is a literal reserved here. The most common search is actually going to be the resource-based search. So that's the second line there. And in the case of the get, you're just adding the resource name after the base URL. So you have your URL /patient /encounter /observation, whatever you need to do, medication request, and search for it there. And then same thing with post. You just take that same URL and add the path segment of _search. The last one, and this is one of those asterisk ones, is a compartment context. And this is a way of scoping your search to say everything belongs to a group based on this resource. So the most common is a patient compartment. So you say, for instance, I want to search for all encounters, but I really want to search for encounters where Wistra is involved. So instead of looking for the encounter resource and trying to map all the IDs and keeping track of all of that, on some servers you can say, go to the URL you would use for Ward's record, resource ID, and then you can do a search based on that. So it's an interesting thing. It sounds like it would be super useful and super common. It is pretty useful, but we also have to remember that most HTTP servers have some sort of security context that's already in scope. And so it's not actually as necessary as it sounds, because in a production server, if you go ask for all patients, you can only see the patients you're allowed to see anyway. So it's kind of this mixed bag of it's something that's very useful on test servers and in test workflows and things like that. There are some use cases where it's very useful as well, but it's not quite as common. So it's going to be hit or miss on if your server supports it or not, and if you need it or not. But it's useful to know it's there. Search responses. As I said, it's not an array of the resource. It is a bundle. So if you haven't seen a bundle, it's a container type of resource that just holds other resources. There's a bunch of different types. In our case, the only one we care about is search set, because anything that comes back from a search is going to be a search set. There's documents, document references, there's messages, there's all kinds of different ones, but that's all we need to worry about. It can be in whatever MIME type. So if you're using XML or JSON, both are fine. It does have metadata. And so one of the most important things, it has links. And as I note here, there's like the self link, the next link for paging, the self link, previous link for paging, the self link, last link for paging, the self link, which we'll get to here in a minute. But that is the most important, the first among all of them, we'll say. It also has entries, which is what you're hopefully searching for. So it actually has a few different types of entries. It'll have the things you asked for, which are called matches. And so there's an element in there, search mode, I believe it is. And that'll say it's a match because it's the thing you asked for. The server is also allowed to include other things, either that you requested or that the server thought you would want anyway. So maybe you asked for a medication request and the server's like, yeah, we also happen to have a medication dispense for that. And it's going to throw it in even though you didn't ask for it. So it's allowed to do that. You need to check if you are running a search, check these types of things to see what you're getting back and make sure they're what you think they are. And then the last is you can have 0 or more operation outcomes. And these are the FHIR status messages, if you will. So they can be info, error, warning, fatal, different things like that. And it's just additional information. So as with the security note underneath, that you don't necessarily get all of the responses. If you don't have permission to see something, it's not going to come back to you in the search. Some servers do things like every search has an operation outcome warning you that there might be more data you can't see. So it's just there reminding you to say, yeah, there could be something privileged and you'd have to go through the break the glass protocol in order to get access to those records. That's always true. You don't necessarily have to say it on every search result, but legal departments will do with you what they will. So as I mentioned, the bundle type is search set. The links for paging, those are the simple ones. Next, last, previous, this is all built in, which is really nice because then it's not up to a server to figure out how to do paging and a client to integrate with that server's paging mechanism. It's part of the bundle. You just have to deal with it. I'll note that these links are opaque links. So a lot of times, especially on test servers, it's going to be, you know, the query that you sent plus an offset or an account or something like that. That's great, but it doesn't have to be that. And there's actually recommendations that servers don't do that in case there's PHI or things like that, because these links could be logged in different places. So even if they look like the search link or things like that, they are just opaque links that says, get me the next page, get me the previous page, get me the last page, things like that. The one that's most important there, like I said, is the self link. And what that is, it sounds like, well, it's just the link you called, but it's actually the server's interpretation of what you called. So that is going to be where you can actually check to see that the server understood the search parameters you gave it, that it didn't lose something in transit, all of those types of things. The server puts, this is the search that I actually ran into the self link. And so if you ask for things that aren't defined on that server, it'll return you more results than you asked for, because searches are all about filtering. But you just need to know that as caller. You need to say, oh, it did not understand that I was asking for patient last name, which would be a weird thing not to understand, but sure. Then it's going to have all the patients, and I have to filter for the last name myself client side. So the position has just been the server can return you more data than you asked for instead of making you re-ask for that it doesn't understand and then go through it again anyway. As I mentioned, there's a VS Code, REST client extension, links to those things. They're all free open source stuff. And then files are on GitHub in their Postman collections. And I'll just show, quick, the HTTP one. Let me zoom in a little because I'm sure that is way too small. So we can see, in this case, we're using just an open Azure open source server. This is there, so you can play with it too. Feel free. And that is our base URL that we're going to use in everything else. When we get down here, we're going to use the patient resource because that's just as easy. And then I have a patient ID for things that we need a patient ID for. And these are just variables in this file name. So we can see we can do things like a root server search, send a request, and make it so that we can actually see the response. And we can see here we're getting a bundle. I'm doing everything in JSON because I think JSON's easier to work with than XML. And that is specifically for my heckler in the front row. But you can see it's a bundle. It does have its own ID. You can't actually retrieve these later. These are transient resources. As we said, there's that important search set type. And we can see some links. So the next page, you can see, and in this case, you can see that it is just an opaque link with some sort of token, key, whatever it is. And so all I know is if I click on that and go through, it'll give me the next page of results. I don't know what's in it. I don't need to know what's in it. And then the self link, in this case, you can see it's just an empty URL, the bare URL, because I didn't ask for any parameters. And then we have the entries. So since we didn't specify a type or anything, we're just getting allergy intolerance happens to be the first types of resources alphabetically on the server, and that's what it wanted to start returning. So it's just going to start returning all of those, and it'll return a page worth. Same thing, I'm not going to go through all of the examples just for time reasons, but you can see the same thing with the post. It looks exactly the same. We actually post www form URL encoded data. So in most things, obviously, when you post in FHIR, you're doing in XML or JSON. In order to keep the search processing consistent, it's always URL encoded. So in the get, it's query parameters. In post, it's URL encoded post data. And that way, it's always handled the same, it's always encoded the same, and there's a lot fewer opportunities to mess that piece up. And same thing, we can go through and get or post based on the resource, and we can do the same thing for instance, encounters within a patient or things like that. I will note on the compartment search, the compartment definitions could be a whole nother talk on itself. It's not just the ones that you are the patient for necessarily. It might be where you are party to them, depending on how things are referenced. So for instance, if you have a dependent you're caring for, and you are at their encounter and provided medical information, you might show up in the system linked in the compartment or not. It depends how they're doing their linking and things like that. So there's some gray lines in compartment definitions, and that's worth noting if you're trying to use them. Okay. So search parameters. Again, as we said, searching is pretty pointless if all you can do is ask for everything all the time. So we use our search parameters. Now, what's interesting is these are actually defined as FHIR resources. So they are canonical resources. You'll see that term. Canonical is just definitional resources, questionnaires, search parameters, subscription topics, all these kinds of things that are kind of their own thing on their own instead of like a patient that's representing something else. Those are just domain resources. So they're actual objects you can go look up. They're in the core spec. They're in implementation guides. And yeah, that's how you add them to systems in a lot of cases too. Scope can be either system-wide or one or more resources. And then there's a few key elements here. The first one is the expression. So that's the thing that you're using to map from, asking for a patient's name into patient.name.family or .given, things like that. So it's the way of relating the search parameter, which is just a query key, a short, nice name that you can use, into where it is actually nested into a FHIR resource. So that's in the expression. And then the other key thing really is the type. And this is to map from that URL encoded data into the FHIR data types, right? In FHIR, we have, for instance, a codable concept that has system, type, code, version, all these things. So how do we get from a string into that structure? And so all of those things are mapped here. How are dates encoded? How are times encoded? All these kinds of things are based on these type mappings. Generally, they are kebab cased and in lowercase, and I love saying kebab case, and so that's why I get to say it, but they're hyphenated because most people don't know that that's called kebab case. It's fun minutia. So, and then as I mentioned, core stuff is always generally underscored with the prefix with an underscore. So things like ID, which we'll use as an example here in a minute, it's on every resource. We're not going to make every resource go through and define its own ID search. So there's just a global underscore ID, and we don't have to worry about conflicting with anything. As mentioned, defined does not mean supported, but if it's in its capability statement, it is supported. So you can look at a server's metadata endpoint, its capability statement, and for every resource, it'll list the search parameters it does by name and hopefully by canonical URL as well. Note that the name gets to be overwritten by the server if they want. So generally, when you're talking about core things or in IGs, they'll specifically say, you know, the patient name search parameter has to be exposed as name. But you might have 3 or 4 different types of name searches you want to run on your server. And so you can call them name 1, name 2, name 3, name 4, name 5. And whichever one you want as a server implementer, you can call name. That's perfectly valid. It's just that there's also the URL, and that's how you look that up, is in the capability statement. As far as the core ones, they're all in the search parameter registry. So they're all listed there. And then every resource has them at the bottom of the page as well. So search parameter types, wall of text. Apologies. I thought it was worth putting in a slide just because it's there so that you can look at it yourself. But these are what I was talking about, those type mappings. So you have date time, or date time, number, quantity, reference, string, token, URI, special, which means do whatever you want. There are very few special things. Those are for things like geolocation that we don't have a great grasp of what the format necessarily is in how to ask for a location near a facility. Or a Gino location, yes, thank you. Yeah, so those in special, when you see something that's special, it will have all of its definitions for everything, and pretty much none of the other rules necessarily apply. The other one I want to kind of draw attention to is this composite one. I've mentioned a few times, like patient name. That's actually a composite search parameter because it searches on family name, given name, all these other parts of the name. There are specific ones that are just, for instance, string, such as family. So family is just if you want to search on the family name. Given is just if you want to search on the given name. Name is a composite search parameter that works on all of those parts. And we'll get into some more examples here. But there are the types and the links. I don't expect anyone to read them right now. Whatever. So some standard search parameters. Again, these are the common global things that everyone would want to have defined, and we're not going to make everyone go and define themselves. So again, prefix with an underscore, underscore ID, last updated, so when a resource has been changed, security labeling, tags, all of those types of things. Again, there's links to them so you can browse them, but it's just to know that there are search parameters like that that apply to everything. Again, there are examples. I'm going to pick ID here just as one of the global ones. You can see it's all broken up. All of these things are listed. The logical ID of the artifact, it's a token type. It's defined on every resource. There's the format for it, an example. Some people might be asking, why would you want an ID-based search? If you have the ID, you can do a read. And it's really that there are a lot of benefits to using search instead of read. As far as things like including additional resources. So if I want a patient and all of their encounters, I can do that in a single search. I cannot do that if I'm doing a read in one query, because I do the read of the patient, and then I have to go back and read the encounters. So there's a lot of things like that that you can do additionally if you're doing a search instead of a read. Also, you get back a bundle, which is a little more effort, but that means the server can give you additional resources, can give you additional operation outcomes, do different things like that. And again, there are demos for all of these things, but time-wise, I'm going to skip over a lot of them. So resource search parameters for patient. I started listing them out here. I can say, there we go, make this a little bigger so we can see. If you go to like the patient page, you can come up to the bottom, and then there are all the core defined search parameters for patient. If you look at an IG like International Patient Summary, I think that's, I can never remember IPS or IPA, which one has that kind of stuff, but, or US Core, they'll have additional search parameters to say, here are, you know, for this extension we defined, here's a search parameter, or specific thing saying you have to actually expose birth date as birth date, so that those can be pinned to regulations and things like that. So they're all here, and you can see links to all the types and everything else as well. So example here, again, searching by patient family name, and that's not all that interesting. So we'll try to get to more interesting stuff here. Search result parameters. These live in a very interesting space, and that is that they've always been defined alongside the search, like the global search parameters, but they're not search parameters. So when you talk about something like a sort, or if you talk about changing to a summary view of resources instead, that's not part of your search, that's part of your result format. And so they're defined in the search page, they're there, they look like search parameters to a lot of things, but they can't be in the search parameter registry because they don't have expressions and they don't have things like that. So it's a work in progress to see how we can surface these better so that a server can advertise what it supports sorting on, for instance. But at the same time, that would be a very large computable definition if you said everything you can sort on in every combination in every order. So there's a little work to be done there. But for most intents and purposes, we can treat them like search parameters. We just want to keep in mind that they aren't actually search parameters. So sort is a good example. It's a token base thing, and the keys are the other search parameters that are defined. So in this case, like we're using family to sort by the family name. And then you can prefix with a minus or hyphen to do it in descending instead of ascending order. And so again, it looks just like a search parameter, but it's not. Then we start getting to the fun stuff. So modifiers and prefixes. It's great to say we want to search on, for instance, even just family name. Like, okay, that's a pretty straightforward search. How does the string search actually work? Well, when you look at a string search, it's defined as starts with or equals and case insensitive. That's the default string matching that you use in a search. Okay, but what if I need to know, I only know part of a name and I need to search on contains? Well, you're not going to find a second search parameter, family hyphen contains to do that. And so we have a modifier that you can attach to family that says, yeah, contains. Or, well, I have a list of them here in a minute. But these are going to be based on the type. So tokens have specific ones, strings have specific ones. All of the different search parameter types have modifiers that can be applied to them. And then there's also this other set of things called prefixes. And these are going to be non-string value things. And so these are things like dates or quantities is another good one. If you want people born after January 1st, 2022, same thing. Well, you're searching on birth date, but you want to give it this open-ended date range. Okay, well, what you can just do is put, greater than and your date. And that way it's part of the string processing in the same parameter instead of needing to define 15 parameters for every single value of, contains, is, ends before, all these different things. So you can have one or the other, you cannot have both. So if you have a modifier, you do not have a prefix, and if you have a prefix, you do not have a modifier, and that's just because it's trying to map between them doesn't make sense. So modifiers first. Modifiers are attached to search parameter names with a colon. So sample is missing here, and so you do like family colon missing equals true. So you can see in this case, we changed family from a string search to a token search that's true or false. And what we're asking is that element present in the resource? So it's not about the value anymore. Now it's just saying, is that value there? And so that's a good example of a modifier, just to say, yeah, it's completely changing how you're processing the search parameter, but it's still the same element. We don't want to go through and define this on every element again. And that's why it's a modifier. I'll note that a server is required to reject any searches that it doesn't understand a modifier for. And that's because if they went and searched for the literal true as part of the last name, that would be giving you some very odd results. And so it's much safer to just say, I don't understand this modifier. You have to do a different search. This one I do want to dive into a little bit more. So you can see here, this is the patient family name modifiers. And so these are string types. And the default, as we said, was case insensitive, starts with or equals. Then there's a contains. So it's a case sensitive contains match. You can do :exact. So then it's an exact match, case sensitive and matches exactly. And then there's text, which is advanced text searching, which doesn't make sense in family name necessarily. I guess you could do phonetic searching and things like that. But it's really more for things like I'm looking for anything that mentions a body part liver. And you're looking just text liver. And you don't care if it's coded or not or anything like that. You just want to see those results. So let's see. That is modifier patient family. And so we can see, I guess the slide probably had as much good here. If we're looking at a family name of Abernathy 524, because this is Cynthia data, props to the MITRE team. Cynthia is outstanding for generating fake data. I'll plug that because it's a great project with great stuff. So you can generate a bunch of fake data and it puts names with numbers and things like that so that it's not colliding with itself as it's generating. But we have this Abernathy 524. If we send a normal request with Abernathy, and I'm not going to worry about seeing the response as much, as you can see that it found the record. So we said the name starts with Abernathy, it found it. We can change the same thing to a lowercase a Abernathy, and it still finds the record. And we can see our self link is coming back and showing us that correctly. But if we try and do a family name search of 524, it's not finding it. And that's because, again, we're looking at starts with, and 524 is the end of the patient record. But we can add our contains, and then we have our record again. And same thing, exact forces case sensitivity. So here we have Abernathy with a lowercase a, and it does not find the record. And then here with the uppercase A, it does find the record. So there's a lot of detail in documentation there about how you handle Unicode, character expansions, replacements, all these kinds of things like that. That's all detailed in the spec, and way too much detail to get into in 45 minutes. So if you're interested in that, please take a look. But generally speaking, exact is going to be exact match, and the rest of them are pretty straightforward in what you can expect the implementation to look like. So prefixes, as I mentioned before, these are on non-string values. And that's because they literally just have characters that are prepended on the value. And so if you're sitting in front of, if your string just had a GE in front of it, it'd be very hard to tell if it was part of the string or not, and all those kinds of things. So this is on things that are not string typed. Dates, quantities, date times, numbers. I don't remember what else off the top of my head. But there we go. So same thing, example for patient birth dates. And you can see that there's equals, not equals, greater than, less than, greater than or equal to, less than or equal to. And so you can see now we can use that same birth date search parameter. So it's only the one search parameter, but we can check for people born on this date, after this date, before this date, date ranges by using multiple parameters, multiple copies of the same parameter, all these different things. So we can say, you know, born after January 1st and before January 31st. And so that's all possible with these prefixes. And same thing, I won't go through all the queries, but if you are interested in playing, there is a set of playing with the birth dates, and you can see how the results come back differently. All right, so multiple parameters, same thing. Now we can ask for one thing, but one thing only. That's not as useful as we probably want our search to be. We want to ask for multiple things. And so we need to be able to join these parameters. Oh, I'm getting short on time, so I'll try to wrap this up as quickly as I can here. Really, there's a few types. The AND is easy because these are query parameters, so you just join them with ampersand, right? So if you want family name is Canessa and given name is Gino, family equals Canessa and given equals Gino, done. Pretty straightforward. Or joining is harder because we have to be able to join with and the other way. And so we're pretty limited in what we can do. And so internally, each search parameter can actually have commas. And this comma syntax is defined, and again, there's links to all these things, but you can do like Canessa, comma, Wistra, and then you would have searches for Ward or myself in that same value. If you need to join different parameters as ORs, use two queries. There is not a way to join them in a single query. And while I sound like I'm joking, that's actually the thing you should do. And to that end, you can batch queries. And again, we're not going to have enough time to dig into all of that, but essentially you can just send a request for 2, 3, 4 n queries. The server will run all of them and give you back a bundle of search result bundles. So that's the important thing to keep in mind is you get back a bundle of bundles because you're doing a batch of searches. And then the last one is if you're defining something and need multiple parameters in multiple values in FHIR and all that stuff, you can define a special search parameter, like we said for name, that can do composite, that can do all these different things. So you can add in lots of additional logic if you can define them. I am almost out of time, so I just will briefly touch on chaining and including. Chaining is when you are searching through resources. So you're saying that, for instance, I want all of the encounters that have a patient who has a name of Canessa. So that's called chaining. And so what you're doing is following links that are references in resources via search parameters as part of your search criteria. Including is when you're saying, yeah, I want Canessa, search for Canessas, and I want all of their encounters. So you're saying, give me the patient and include all of these other resources with it. And same thing, you follow references through resources, but you're adding them. And both of them have a forward and a reverse direction defined. Again, servers may or may not accept because encounters list patients. So if you want to go from encounter to patient, that's easy. If you want to go from patient to encounter, that's a more expensive query. So you signify that differently, has and rev include instead of just chained and include. And there's examples of all of them there. And there's plenty more. Like I said, batching, there's transactions, advanced queries, messaging, contained resources, external resources, lots more to see, but that's about time. So I think we have maybe a minute or two left for questions. I don't know. Ward's playing the music, maybe? I don't know. No, he's grabbing the microphone.
Yeah, that's it. I kind of tricked you because I wanted to make sure that there's some time. That's
perfect.
Questions, actually. So
all right. So there is time for questions.
Definitely have 6 more minutes or something.
Oh, outstanding.
There's definitely questions in the room. That's great.
Please.
There's also questions online, but let's start here with this gentleman.
Okay. Your last couple of slides with chains and batches, it sounds like we're creeping up on cohort searching. Can you comment on the relative efficiencies of doing it that way?
So generally, servers are going to be optimized for their search parameters pretty well, and they're just not going to expose the parameters that aren't. So, obviously, if you can reduce your cohort search into a set of search parameters that are nicely indexed, I think most server implementers would give you a big thumbs up on that. Whether it's inside a search itself or inside, characteristics inside a group or anything like that, at the end of the day, it's the same data and we're indexed and searching against it. So, but definitely if it's an advertised search parameter, that will always be pretty well supported by the server. Hopefully that helps.
Thanks, Gino. Maybe a question from online. We had Vlad asking online, given that the search parameters are sent via the URL, isn't there a technical limit to the length, especially since some characters are being escaped?
Yes, there is. And that is, sorry for the quick scrolling here. That is one of the things that is nicer in the newer link for transport protocols. There we go. On slide 6, this link to the CI build on transport protocols has more of a discussion on get versus post. So obviously, if you are running into the technical limitations of a URL in your get because you have a lot of value sets and code systems and things like that that you're expanding out, use a post instead. The updated guidance for that, which I don't know if that made it into R4B or if it's going to be official in R5. It used to be post was mandatory and get was mostly optional, but it was very fuzzy language. So now we clarified it that everyone has to support both, but the server can return use the other one. So HTTP method not supported, they can tell you to use the other one. And that way you can figure out for your use case, you know, if you're trying to list facilities in a directory and you want to be able to cache them, you don't want to support post because you're not going to be able to cache those results in a CDN or anything like that. You want to be able to use get and turn off post, and vice versa. If you have too long of a search, you want to be able to mandate post and not use get. So essentially there's both and go from there.
So when I said to Vlad, yeah, probably use post instead, he said, you'd be right. Even in post, the parameters wouldn't be send URL encoded to. Does that make sense? Are parameters still being send URL encoded?
They're URL encoded, but they're the post data. So it's XForm URL encoded data.
So there's not really a length.
It's whatever the server is going to accept as a post. So there are still limits, but if you're searching for more than 2 megabytes of data, which I think is a pretty common one in your parameters, then you probably want to switch to _query, where you can build a named query that contains all of that kind of additional information.
Hey, so a lot of the FHIR search API reminds me of kind of building towards SQL in kind of a weird way. Has anyone thought of like grouping or uniqueness? Like I find myself loving to do a get me all the encounters, the most recent encounters grouped by a patient. So I only get like a unique list of encounters in that case.
Yeah, to my knowledge, a lot of, that's a great question, Brian. Thank you. To my knowledge, a lot of that is being covered in GraphQL type stuff, saying if you want really advanced capabilities like that, then switch to GraphQL. The support on GraphQL is, we'll say, more miss than hit, though, at this point. And part of that is just the realities of saying things like, I have a modifier element in a resource, but I didn't ask for it in my GraphQL shape. So what do I do? Does the server inject it anyway? You know, some of those types of things are complicated, but yeah, I think that those more advanced searches are coming up. You know, as FHIR gets more and more widespread, more use cases are covered. And I would say if there isn't anything like that, that a proposal would probably be nice.
Great. One more online question on the subject of search parameter names.
Yes.
Was it stated that implementation guides can change the name of a search parameter?
Not implementation. Well, I guess implementation guides can. When you go to add a search parameter in your capability statement, you can actually name it whatever you want. So the name, there is a name defined when you define the search parameter, but in the capability statement, you can call it whatever you want, and that's because you can have collisions. If you have 4 IGs that defined, you know, patient query as the search parameter or patient cohort search, you need to be able to distinguish them on your server. So the server itself is allowed to change those names, but they will be in the capability statement, and they are supposed to have links to their canonical definition so that you can go do more investigation. Generally, they will. Some servers are better behaved than others, but that's reality. Yes.
You mentioned earlier the read versus the underscore ID search.
Yes.
One of the things I've observed is that the underscore ID equals, you can do 111, 222, 333.
Yes.
Which is one of the ways we're using it.
Yep.
Is that in the spec, or is that
Yes.
just like a citizenship thing that people are just doing?
No. So yeah, that's the joining in a single parameter with OR. So that's all you're doing is saying, yeah, I want to do a search and I want the IDs
I would
to
love
be.
to go back in time and change that to underscore IDs because that causes so much confusion. But thank you for pointing that out.
Yes. In general, FHIR wants, it's actually a warning when you go to define an element, if you define it plural. And that's just because the way the modeling is, they're saying if you have two of them, each one is still, and a lot of that ties actually back to XML in the way the elements are. That it's odd to have a pluralized element that repeats. And so in general, things in FHIR are going to be in the singular. Oh, it does cause a lot of confusion, especially when the element contains something that is plural of data. You have to go get an exemption from FMG in order to be able to name your element that way even. So.
Okay, thanks so much, Gino.
Oh, thank you. Perfect. The quick shameless plug, because they do give me a paycheck, which I approve of. There's a slide there of other talks from Microsoft people. So feel free to check them out. I have a couple more on here myself. So that's there. And thank you all.
Thanks, Gino. If there's more questions, there is one more online, for example. Feel free to post them in the Q&A of Whova. And everyone on site can, of course, just find Gino.
I'll be here. I'm here all week.
For example, at the reception tonight.
Exactly.
Thank you.
Thanks.